As an extension topic, we will have to learn about linear convolution through circular convolution and some differences between both of them. So if you look over here, I have already used for easier comparison, we use the sequences that we had used upon earlier. X of k is 1, 2, 3, 4 and h of k is 1, 3, 5, 7. And the output of the circular convolution between both these two signals were 42, 46, 42 and 30. I am doing the tabular method for computing the output of the linear convolution between these two signals using the same concept that was explained in the previous videos. So you have 1, 3, 5, 7, the sequence arranged here. You have 1, 2, 3, 4, that is a sequence arranged here. You multiply each element by element and then you take the elements diagonally, and in the end you get the resultant sequence as 1, 5, 14, 30, 41, 41, 28. Now if you look over here, two signals, a set of two signals, they generate different outputs for circular convolution as well as for linear convolution, which should give you an idea that both of these are two different processes. Now we have the circle. So our normal concept of an output for circular convolution will be of length L1 or L2. So since L1 is 4 and L2 is 4 over here, for circular convolution your output is max of L1 or L2, which is still 4, and you have 4 sampled sequence as the output over here. But for the linear convolution, the length of the output sequence will be L1 plus L2 minus 1. So 4 plus 4 is 8 and 8 minus 1 is 7. So the length should be equal to 7. So if you compare it over here, you have 1, 2, 3, 4, 5, 6 and 7 elements, which ensures that this is the output of the linear convolution. And with regard to the starting point clarity, both these signals start from 0. So hence the signal here also starts from 0 and here also it starts from 0. So I hope those signals these concepts are familiarized. Now our topic for concern is linear convolution through circular convolution. As I just explained, for performing circular convolution and for performing linear convolution using the same set of signals, you get two different outputs. Then how can I get the linear convolution output using circular convolution? So that is a topic here. So which is why I had made a brief expression or concern about the length of the output sequence. So here the length of output sequence of LC or linear convolution is 7, as it is clear from this particular output obtained. So I am supposed to obtain this output using a circular convolution operation. That means if length of output is of CC, that is circular convolution, is max of L1 or L2, if this is equal to 7, it will imply that L1 or L2 should be equal to 7. So when we modify these two sequences to length of 7 and perform circular convolution between those two signals, we should be getting the output of the linear convolution. So for that particular case, I am modifying my x1 of x of k as 1, 2, 3, 4, 0, 0, 0, and this process is known as zero padding as explained in the previous video, and h of k becomes modified as 1, 3, 5, 7, 0, 0, 0. 3 signals being added. So as mentioned in the previous part, we have a modified x of k and h of k as 1, 2, 3, 4, 0, 0, 0 and h of k as 1, 3, 5, 0, 0, 0, which is shown over here. And you should be performing circular convolution between these two signals, and we have to prove that by doing that you get the output of the linear convolution. So if you want to plot those signals, we need 7 points over here. So let me take a different color and we'll mark 7 points. So this is a starting point. We mark 7 points. 2, 3, 4, 5, 6 and 7. Just aligning that we have the same set of values. Okay, we have the two concentric circles, so this will be representing the x of k signal, and as per our logic the inner circle will be done in the anti-clockwise manner. X of 2, x of 3, x of 4, x of 5 and x of 6. So this will be like 1, 2, this will be 3, this will be 4, this will be 5, sorry, this will be 0, sorry, this will be 0, and this will be also 0. Now h of 0 element, it will be starting from here but in the clockwise order. So h of 1, h of 2, h of 3, h of 4, h of 5 and h of 6. So this will be like 1, 3, 5, this will be 7, this will be 0, this will be 0, and this will be 0. So to calculate y of 0, what you do is you take the product and you sum up. So 1.1 plus 2.0 plus 3.0 plus 4.0 plus 0.7 plus 0.5 plus 0.3, which remains only as 1, which is the first output that was to be obtained here. Now if you want this to be rotated, y of 1, if you have to do that, you have to rotate the signal once again, the outer circle in the anti-clockwise manner. So we have, what we have drawn here is basically the signal h of minus k in the clockwise order, and if it has to be shifted one place, then it has to be shifted in the anti-clockwise direction. So to calculate y of 1, we have to shift the signal that was existing here one place in the clockwise the anti-clockwise direction. So this becomes h of 0, this becomes h of 1, this becomes h of 2, 3, 4, 5 and 6, implying this becomes 1, this becomes 3, this becomes 5, this becomes 7, 0, 0 and 0. So to calculate y of 1, this becomes 1.3 plus 2.1 plus 3.0 plus 4.0 plus 0.0 plus 0.7 plus 0.5, and when we sum it up we get it as 3 and 2, which makes it equal to 5, which is the second out here. So as you rotate the signal along in the anti-clockwise direction and computing performing the same operations in the manner that was explained before, you should be able to get 14, 30, 41, 41 and 28 in the successive order, which gives you the output of the linear convolution through circular convolution. Now I hope this method is clear. So moving ahead, as a last part of this video, we'll take a look at the difference between linear convolution and circular convolution. So as said over here, the length of the output sequence will be L1 plus L2 minus 1, and here it will be max of L1 or L2. The starting point of the input output sequence will be the starting point of sequence 1 plus starting point of sequence 2. Depending upon the kind of sequence, it can be a non-zero value, but for circular convolution it is always 0. And the nature of the signal, it can be periodic or aperiodic, and it is mandatory that it should be periodic in circular convolution. And with the technique called zero padding, it is not required for linear convolution, and it is required in cases of circular convolution. With these the inputs, I hope the topics of convolution, linear convolution, and circular convolution is clear.